Hello and welcome to another 3D survey webinar. Today Wid and I are going to show you how to use RTK video and laser data in your photogrammetry workflow. Or in other words, we're going to show you the 3D survey modules. 3D survey modules were developed for the version 3.0 and higher. The first one is SCAN module. This one was developed for 3D survey users who would like to shift their photogrammetric workflow more towards the point clouds obtained from laser scanners, SLAM devices, or just LiDAR data. 3D survey itself already enables you to work with all those point clouds. What the SCAN module brings to the table is additional features and possibilities. The first one among them is manual registration. Combined with automatic registration, they can be used to align your point clouds that are not georeferenced to the right coordinates. We'll look at this feature in a separate video right now. Now here we have straight out of scanner situation, where we've got 4 unaligned point clouds. Now let's get those point clouds properly aligned. We'll start with point clouds 1 and 2. To start, find the manual registration button in the bottom row. The manual registration window will open up. Here you have 2 windows. The left one displays a point cloud that's going to be aligned, and the right one is the reference point cloud. First, zoom to the vantage point of your point cloud, so you see what you saw from the standing point. Do this for both point clouds. The alignment works on a set of identical points, so you have to find at least 3 points that are common to both point clouds. A pretty easy and obvious choice would be this corner. Mark it on both point clouds. Now let's continue with the second point. Let's pick this corner on the upper level. If needed, increase the point size to see better. You can do this separately on each point cloud, like here. For now, don't mind the error numbers. Let's find the third point. Let's pick it on a car. Just make sure it's well visible on both point clouds. I will choose this headlight corner, like so. And now that we have 3 points, we can inspect the error numbers. They're all well under 2 centimeters. And now we're almost done. There are some additional options here in the center. You can fix the scale and lock the Z-axis. I have both of these on because my point clouds are all from the same source and on the same elevation. When you click register, you'll be taken into the transformation preview. We can check our result if we toggle on and off one of the point clouds. Here are the transformation parameters, and a very important notice, keep this box unchecked. Now let's examine our results. I think we can be pretty happy with them. So here's that same wall just colored, so we can see the discrepancy a bit better. Now we'll use automatic registration to fine-tune that alignment. But before we go into that, let's take a measurement of just how big of an error are we talking about right now. I'll select the 2D distance in the CAD module and take a measurement between the yellow and the magenta wall. Like this. So it's a 7 centimeter error. Okay, back to point cloud. You'll find the automatic registration button in the bottom right corner. A new window opens up which lets you set the reference cloud and the clouds you want to align to it. We set the mode to normal and just press match. Depending on the number of point clouds and the points in them, this could take anything between a minute or an hour. So in about 2 minutes we got the result, and here we will see the difference immediately. We can see that the gap between the walls is reduced, but still present. For the purpose of this webinar, we'll repeat the measurement and go over the process again. This time we'll set the mode to precise, which usually takes more time since it does more iterations. But since we're starting off from a very small misalignment, the process was over in less than a minute. So now we finally got our walls merged together. We can return them to their natural color and see the complete result we got through this point cloud registration process. So there you have it. We successfully registered our non-aligned point clouds to fit together perfectly. And now you know just how to do it yourself. Okay, the next feature I would like to point out here is X-ray views. X-ray views expand on the idea of X-ray orthophoto. That's already a accepted feature in 3D Survey for a few versions now. And what this does is brings X-ray to all three axes. So basically you can have vertical sections and multiple layouts of a single object. Now let's just jump into the live demo. So I have a project here that was done combined with photogrammetry and we have also the scan of the inside done with laser scanner. So this is our photogrammetric point cloud. And you can see it's pretty nice on the outside. And on the inside, we have this point cloud. It doesn't have color, but that's not really bothering us right now. All that's important is that it's quite detailed and that we have successfully aligned it using manual registration with the photogrammetric point cloud. So now we can create the outside and inside structure of this 3D model. So we go here to X-ray views, calculate new X-ray views. Now this is a sort of familiar dialog that was here also when you use this X-ray, classic X-ray. And today we will not go very much deep into the technical part of these parameters. I will explain them quickly. Maybe we should stop with the first one here. So the source point cloud can only be one single point cloud. So make sure you merge, if you have more point clouds, merge them into a single point cloud. That's available here. So then you have target resolution and color transparency. The resolution is tied to a fact that X-rays are orthophotos. So basically it's the same as the orthophoto resolution. We'll set it here to 1 centimeter per pixel to be, that's quite accurate to be fair. And the color transparency is sort of a strength of pixels that are flattened along the axis and combined. So the higher this value is, the more transparent those pixels will be, meaning they will have smaller impact on the image. So if you imagine the lower the transparency is, the more you can see, the more stuff you can see, the more pixels you can see. So if you have a dense point cloud, crank this number up to 80 or 90. If it's more sparse, leave it at 70. But anyways, play around with this one a bit to get the best results. We have tried now a resolution of 1 centimeter and the transparency of 80%. And while we wait for these X-ray views to be generated, I can share a bit of a secret with you. We're already working hard on these speed up of this process. We're in final stages, so very shortly we'll release and update that will speed up your workflow. So here we are in the X-ray views. Sorry, I had to change the resolution a bit. Never mind. When you get to X-ray views window, you get 3 X-ray orthophotos: top, front, and right. Now, you may already know the top one. It's the same as the one you can do from the point cloud window. So the first thing you notice here is this one is not aligned with the east-west or north-south axis. That's why the front and right views don't look so, well, useful, because they are flattened together along these vertical and horizontal axes that they are not aligned with. So the first thing you should do here, use Align tool. And this will give us the, well, alignment along the perpendicular axis of north-south and east-west. I measure my angle and just click confirm. This will now recalculate my X-ray and give me the perpendicular image. You will see it will make much more sense when it does. Okay, now our X-ray views have been recalculated to fit the perpendicularity of the north-south and east-west axis. And you can see that the front and the right view now make much more sense. You can clearly see the building outline and even the rooms within this building. But still, everything looks so cluttered. That's because we are making X-ray views from complete point clouds, and they have a lot of information that you cannot represent in this way. So that's where the second tool here comes in. This one will enable us to make layouts and sections. So depending on what we want to achieve here, we shall create, let's say, a floor plan. Our plan is to make a floor plan of the second floor, and we click in the front view. Now we got this red line that represents where our vectorization will snap to. So this yellow buffer zone represents the area that is taken into account when calculating new X-ray views. So everything that will be, all the points from the point cloud that will be inside this yellow box will be used for the calculation. So I want to make sure that this part is left out because of all the clutter on the ground level and the mid level of this floor. And I can also decrease the size of this. I can use the spin box if I want, like this. And okay, just to make my view a bit smaller. When I click confirm, new orthophoto layout will be calculated. It was done pretty quickly, and now this is much clearer. You see the lines of the walls very clearly. So we have the outside wall and the inside wall. There's the door and a window and everything like that. Some stairs. And similar way, I can do also the section of front view of the facade. That's what I can do on the top-down view. Click inside, drag the line, and again this red line represents the line where all my vectorization will snap to when I start it. Here I must be careful to leave the cars out and the indoor walls. Okay, I think it's quite good. And let's see what we get. This is the front facade, the entrance, windows, balcony, and the roof line. Looks pretty good. And the best part of X-ray views is you can immediately start your vectorization right here. Okay, I will start drawing lines on my facade. Let's say I want to vectorize this door. Okay, just click here and I go around. You'll be using the currently active layer, so you can see I pre-prepared a layer with specific color and a line weight. When I go around like this, if I misclick like this, I can use backspace to erase the last vertex. That's the same as in CAD engine. Okay, and this is my door. And another very nice thing about this is when you go back to CAD, you can see this in 3D. So it's right where it needs to be. And the best part of everything, I've already done some vectorization, is that this all vectorization is saved on a surface of specific coordinates. So it's all on a single plane. All the windows are aligned. And if I was to vectorize, let's say this layout, the ground floor, the second floor, let's use the floor layer. And if I draw here, all my lines that I draw on this layout will be in the same height, because that's what you need when you're doing floor planning. You don't want your height coordinate to be jumping up and down. You want it all on the same Z level. Well, maybe I should finish this one and just let you, oops. Okay, and in CAD I can see this up here. Very nice. Okay, so this was X-ray views, and all the CAD lines can be exported through here, save CAD, and all these views can also be exported through right-clicking and selecting export. Okay, I hope you find this useful, and let's move on. Okay, another minor but still very nice feature of the SCAN module is the ability to view additional attributes. So, talking about attributes like intensity, scanning time, and return data. Now I think it's best if we just look at the live demo again. So I'll go here. This is another SLAM scan provided by our very good partner Pavel. Pavel, thanks for this one. What I want to show you here is you can view this as a height map. So you can see, well, the height difference, but you can also view it as a scanning time perhaps. Why this would be useful here? Well, if you need to do a job again, or you're just interested what you recorded first, last, and how the sequence went, basically. So you can see here that we started in the deep purple area and then moved to the green one and then yellow, and then we went towards the red one towards the end. So this is one representation. The other one is intensity. This is showing the intensity of the rebound. Now you can clearly see here how different the rebound was on the ground and on the walls, and even on a different tiles in this hallway. This can be interesting in some material analysis or mining bits, perhaps, to recognize the weak zones, or perhaps to see deterioration of materials, stuff like that. And we jumped again. So just a quick mention, there's another property you can visualize, and this is the return data. So you're probably familiar with this one. It just gives you the number of the rebound that the beam took from the surface to the scanner. So yeah, you can see that here on the planes, There was a first return in great majority, and in the forest a bit more was going on. We also get some second, third, fourth, and even fifth returns if we look closely. And yeah, that's just another way of visualizing those point clouds. Okay, now we'll move to the final benefit of the SCAN module, and this is the orthophoto from point cloud. So even something like this can be turned into orthophoto. But let me give you an example of where it may come useful. The orthophoto from point cloud. This one is very useful when you just need to create an orthophoto from your scan. Because if you wander on a project without photos, you simply cannot create an orthophoto unless you have a scan module. So basically it's the same idea as before. You can do custom plane orthophoto or top-down orthophoto. Here's an example of custom plane orthophoto. You just align the box of what you want to include or exclude and simply set the point cloud as your source instead of a mesh. This is the result of orthophoto from point cloud. Okay, so this was SCAN module for you. I hope you like the features. And before we continue to the second module, that is RTK Videogrammetry, I'd just like to let you know that if you haven't tried 3D survey modules before, like if you haven't downloaded a trial for 3.0, you can request a new trial with fully functional both modules for 14 days. So check that out. You can find it on our website right here. Okay, one last thing I would like to add here at the SCAN module part. We are working on so many upgrades for this module that in 2025 you're going to get a whole new level of experience using this module. The upgrades are coming almost on all features, especially on the X-ray views. That's going to be really powerful in the future. Also, manual and automatic registration are improved. So stay tuned. We'll be posting more stuff about this. And if not sooner, we'll see each other in the webinar What's New in 3D Survey 3.1. Okay, now I give my word to you. Dear audience, here's RTK Videogrammetry with Peterman. Enjoy.
Thank you, Mattia. Okay, so now about the RTK Videogrammetry module. So, as you are probably already familiar, even with the regular 3D survey license, you get full access to regular videogrammetry. So that means that you have the ability to record videos and then import those videos into 3D survey and create a 3D model from them. So the downside will be that those models will not be georeferenced. And in order to georeference those models, you will need to use some ground control points or maybe orientate it manually. So I have an example here of a video that we recorded a few years ago. So here we recorded this small excavation site in order to document where this pipe enters our building. And back then we did not yet have videogrammetry module. So then when I took this video and I imported it into 3D survey, I calculated this kind of recording path. Let's come here and have a look. So here is now our model. So this is the sparse point cloud. These are the 3D type points that were extracted from the video. And here is the resulting point cloud and its textured 3D mesh model. So one thing you will notice now, this mesh model is not rotated correctly. Now I can fix that manually by going here to mesh and using transform and add some rotation around X and some rotation around Y axis. And finally, confirm. Then further, now the model is oriented correctly. The next thing we can do, we can go outside and take this measurement. So here in our model, the height of the building is 53 centimeters. I could go outside, measure it, and see that it's actually 58 centimeters. And then I would go back here, transform again, and add the scale factor of 1.2. So increase the height by 20%, confirm, and now our model is scaled. So it works like that, but there is also a better way. And the answer is RTK Videogrammetry module. So with this RTK Videogrammetry module, we get the ability to write into the videos RTK GPS telemetry. So in order to do that, we will need two things. So first thing is our application for recording videos. It's called SideScan. In order to get it, you can go to our website and then under downloads, we go here, 3D Survey SideScan application. You download this one and install it on your Android device. Then secondly, in order to get the full precision of today's GPS, you will also need a third-party GPS antenna for your phone. And there are a number of different ones available, like there's one from Ardu Simple, or Imlit, Stonex, or Trimble. So these are in alphabetical order, not our order of preference. There are also other ones out there, and more of ones are coming out into the market. So armed with all those things, you can then go out and use it to do the mapping. Now here I have a video of my colleague who is doing the recording with this device. So what you will do, you will walk along the object of interest and you will record a video of it. Now here I have a video recorded with our SideScan application. So here my colleague, he walked around this pipe and these valves being constructed, and he recorded this video. So he just walks around and tries to take as a slow and accurate movie. Like that. So after a bit of recording, we can then proceed to 3D Survey and import this video. So we will come here, and now in order to import that video, we'll go here, extract frames from video. As an input file, we will select this one. And for our telemetry extraction mode, we will select here telemetry. So that means that the software will try to prefer frames where it got GPS position. And press OK. So now the software will proceed to extract these frames. The process usually takes, for a minute video, it takes maybe about a minute or so. And now let's wait for this one to finish with the extraction. Okay, we're just about to finish the extraction. And then the next thing to do, we set our coordinate system. So in order to set the coordinate system, you would simply start typing your country name here. So for example, if you are recording in Germany, you would write Germany and select the appropriate zone. This one was recorded in Slovenia, so I'll select Slovenia from the list here. That sets up the appropriate horizontal and appropriate vertical component of the coordinate system, and the geoid model will be applied so that in order we can get for each image the appropriate world or ETRS coordinates. Here we get also our state coordinates with our local grid, easting, northing, and our orthometric elevations. Right, now we finished by closing this one, and we are basically ready to start the processing. So for processing, we could go here and start bundle adjustment, wait for it to finish, and then proceed to point cloud calculation using the reconstruction button. But there is a better way of doing that. What we can do, we can go here to project and use batch processing. And then for each project, we'll just we'll do bundle adjustment with default settings. Orientation, we won't be using ground control points, so we can actually even skip it. We will do dense reconstruction with default height setting and a full 3D mesh. And then finally the orthophoto. This one better if we skip it, because with videogrammetry the camera tends to point more towards forward. And in order to get best orthophoto, the camera should be oriented downward. Because we don't have that, the orthophoto will come out distorted, so here we'll just skip the ortho calculation. That's all there is to set, and we would press run. And then, after a few minutes of processing, maybe up to an hour, we will get to a result like the one I have here. So this is now our same dataset, but this one is already completely processed. And as a result of this processing, first thing we calculated was our sparse point cloud. So the sparse point cloud, so this one reveals the path we took when we were recording the video. Then, second step was point cloud calculation. So this is now our point cloud of the scene visible in the video. And finally, we also calculated a textured full 3D mesh. Then finally, when this is all done, we can come back here into CAD, and in here we can start to place 3D points. So when I place a point here, I can say this point will be valve 1, press point, place it here. If I want to edit it, we can select it, and we can select more accurate 3D position. Valve 1, second valve, let's rename it like that, and move this one just slightly. And finally, the third one. Like so. Right. All of these points that I have just placed, you can see that they already have our accurate state coordinates. Because we were using the RTK telemetry, these points have now an accuracy of, based on our tests, around 10 centimeters. So, additional added benefit of using videogrammetry, now we captured this whole area. So if we want to know, for example, how far away from this curb the new valves are, we can simply come here and we can measure the distance. So we will take here horizontal distance and vertical distance. And as our base, we will use this curve here, and we'll place the first point here on the curve. So this is the curve that I selected. And now if we come to here, we can now see that approximately 2.70 meters perpendicularly from this curve in southern direction at the depth of 2.25 meters, there is the first valve. So if, for example, 10 years or 20 years after this construction has been finished and covered over, we need to find again where those valves are under the ground. We can take certain points from here and use them to assess where to dig in order to find those valves. And that is the biggest added value of videogrammetry, RTK videogrammetry module. It allows us to take videos, which is pretty much straightforward process, use special application and special RTK antenna phone add-on, use everything together to record these videos, and then process those videos into 3D data. Now here I talk very briefly about videogrammetry. So we also have another webinar available. So if you go to our website again, and here under resources, webinars, and then finally we can just search for RTK videogrammetry. There is a number of different webinars here you can check out and get also additional information on the best practices and approaches to doing RTK videogrammetry. So this was a quick introduction to RTK videogrammetry, and now we can finish the presentation part of our webinar, and we can go now to our questions and answers